Bismillahirrahmanirrahim. My name is Muhammad Rizwan. I'm from BS Biotechnology. Today I'm presenting here the topic is electrorefining of metals. First of all, we discuss the content of my presentations. Refining of metal, electrolytic refining of metal, example of electrolytic refining of copper. Property and uses of copper, process of electrolytic refining of metal. Main advantages. Refining of metals such as copper electrolyzes the crude metals used as a anode going into the solution and pure metal being deposited upon the cathode called also electrolytic refinings. Electrolytic refining of metals. The next is what is the electrolytic refinings? Electrolytic refining is a process of refining a metals by the process of electrolysis. As far as the mechanisms of process is concerned, during electrolysis, a large chunk or slab of impure metals is used the anode with a thin strip of pure metal at the cathode. In this setups, an electrolytic metal, salt, aqueous solution depending on the metal is often used. The clean or pure metal is formed at the cathode when the electric current of a sufficient voltage is applied by dissolving impure metal at the anode. Electrolytic refining is also sometimes referred to as electro refining. Here, here will take an example of electrolytic copper refining to understand the process more clearly. Copper is usually mined from its coal known as blister copper. It is about 98 to 99% pure. However, electrorefining process can easily make it 99.95% pure, which make it good product to be used in electrical components. A block of impure copper is taken as an anode or positive electrodes. Copper sulfate, which is acidified with sulfuric acid, is used as a graphite coated electrolytes along with pure copper tube as a cathode or negatively electrodes. In this phase electrolysis, copper sulfate divided into positive ion of copper and negative ion of sulfate. The positive copper or cation travel toward the negative electrodes made of pure copper where it absorbs the electron from the cathode. Copper atom is deposited on the cathode graphite layer. The cathode is coated with the graphite in the process of electrolytic metal processing or morely electrograding so that the concentrated material can be easily removed. This is one of the most growing electrolysis procedures. However, anode metallic impurities are also mixed with SO4 from metallic sulfate in the electrolyte solution and dissolve impurities such as silver and gold that are not produced by a solution of sulfuric acid. Copper sulfate settle down as the anodes slugs or dust. The deposit copper is then separated from the cathode and the anode is replaced by the new block of raw copper at a regular interval from electrolytic copper refinings. The next is properties and uses of coppers. Copper is a major commercial metal. Some property of copper has high electrical and thermal conductivity, easily molded or as for casting extrusions rollings, low corrosion levels, has excellent alloy characteristics, has high aesthetic appeals and low human toxicity. In modern times, the main use of copper is in the form of electric conductor. Copper has very high per unit volume electric conductivity. It can be easily drawn through strings, whatever single or multiply filaments which can be conventional or and regularly twisted without undue tongueless of operations. Copper wire is readily tinned, has superior soldering properties and resistance to corrosion at a point of contact. And the next is process of electrorefining. Electrorefining is much more common process than electrowinning, and such plant occur throughout the world on scales between 1,000 to 100,000 ton years. Electrorefining is one of a collection of electrochemical process which are primarily concerned with the extractions of matter from their ores and or the subsequent refining of metals to high purity. Usually they are part of larger operation to separate and recover pure metal from both scrap and primary ores. Therefore the process must be designed to handle a variable quality metals fields and lead to constructions for all the metal present in a form which can be treated further. Electrorefining process using a molten salt or non-aqueous electrolytic and used in DDID are the subject of further development. This is due to the possibility they from increasing current densities and refining via lower oxidation state not stable in water. For example, refining of copper via Cu plus would almost have the energy requirements. However, aqueous processing presently predominates due to their ease of handling, more developing chemistry and familiarity with aqueous process, liqueurs and electrolytics as a particular high purity of metals. And the next is advantages of electrorefining of metals. The main advantages of electrorefining process are they are designed to handle or wide variation in the quality of base scrub and conversely can provide a particular high purities of end products material. Thank you for listening.